In question 17 we're told that there's a pond which is the shape of a prism, and we're told that the pond is completely full of water, that Samit wants to empty the pond and he uses a pump to empty the pond. The volume of water in the pond decreases at a constant rate. Now that's quite a key thing, because it means we don't have to take into account that actually for this much distance at least, if you imagine this shape here, it's actually a uniform shape, so you'd expect the water to decrease at a constant rate. However, really, when you get to this level here, because it slopes a bit, you'd expect the water to perhaps decrease at a non-constant rate. But anyway, so we're allowed to assume it's at a constant rate. The level of the water goes down by 20 centimeters in the first 30 minutes, so we need to work out how much more time. Now that's the key thing here, and that's probably where I imagine a lot of people make the mistake. It's asking how much more time he needs. So it's saying the first 20 centimeters is done in 30 minutes, but after that, how much time do you need? So just remember that when we come to the end with the answer. So the first thing we need to do is work out the area, the volume of this pond. There's a couple of ways you can do it, but let's do it what I think is the sort of easiest way in terms of how you imagine this. So let's just draw a line across there. Now what we're essentially going to do is we're going to first work out the volume of this sort of cuboid shape here, and then we're going to work out the bit for the rectangular prism underneath. So again, this would sort of go across there, and then that across would go there as well. So that's the kind of shape that we're looking at. So what we're going to do first is we're going to work out the area of the bit that kind of does that, and I realise it's not very well drawn, but that's the bit that we're going to work out first. And in order to work out the area of that, it's going to be a half, which is the height, and again, because we're multiplying these, this actually doesn't matter which order we do it in, but nonetheless, to work out the volume, you need 3 dimensions. So it'll be the height of it, 0.5, times by the width of it, which is 1, times by the length of it, which is 2. 2 times a half times 1 gives us 1 meter cubed. Now the other bit that we need to work out is the triangular bit, and again, to work out the volume of this bit, we're first going to work out the volume of this bit here, which is triangle, and then we multiply it by that width there to give us the overall volume. So again, the volume of the triangle will be a half times by, so we're using the equation here, half times base times height, which is the volume for the equation for an area of a triangle. Then we'll multiply it by the thickness of that shape. So half times by the base. Now in this case, the base, if we think about it, let's just go back to our shape for now, just to make it easier to understand. We need essentially to work out this area here. Now we know that this height here is 0.5. We know the overall height is 1.3. That means this bit here must be 1.3 minus 0.5, which is 0.8. So that means that the volume will be half times the base, which is 0.8, times by the height, which is again the same as essentially the length of the pool, which is 2. 2, so a half times by 0.8 will give us 0.4, times by the 2 will give us 0.8 meters cubed. So when we add those two together, the volume of the whole pool therefore is 1.8 meters cubed. Now that's the volume of the water. What we know is that the volume, or the water, goes down 20 centimeters in its first 30 minutes. So what that actually means is that 20 centimeters, so essentially somewhere around sort of that there, let's say there, that's how much water goes down. But it's not enough to just say it's 0.2, because actually that represents an actual volume of water. If you think about it, it represents all of this here, and it's an actual volume. So again, to work out that volume, we'll do that 0.2 times by this length, oh sorry, I haven't got the pen on, times by this length there, which is 2, times by this length there, which is 1. So again, what we're going to end up with is that we know that the amount that goes down in 30, I'm just doing black, the amount that goes down in 30 minutes, well, we know it's 0.2 in depth, but in terms of volume of water, it's 0.2 times 1 times 2. So that means 0.4 meters cubed goes down in 30 minutes. So that means in 1 hour, the amount that would go down would be 0.8 meters cubed. So we know therefore the rate at which it goes down. So what we then need to do is work out, well, if 0.8 goes down in 1 hour, how long would it take for 1.8 to go? So what we do there is we say 1.8 divided by 0.8 multiplied by 1. Now, since this is a calculator paper, we need to work this out in an easier way. So 1.8 divided by 0.8 is exactly the same as 18 divided by 8. And if we were to do that, we can forget the other part because it's just multiplied by 1, so it will always just be the same. So 18 over 8, so we know therefore 8 goes into 18 twice, and then you have 2 over 8 left over, which is the same as 1/4. So what that's essentially saying is to get rid of 1.8, it's going to take 2¼ hours. So that is essentially 2 hours, and what's a quarter of an hour? 15 minutes. That's to get rid of 1.8. What we have to remember is the bit that I mentioned at the beginning. How much more time after this has been done? So what we therefore know is that 30 minutes have already been done to get rid of the 2.8, so it's the rest of the time. So essentially all we're going to do is take away from there the 30 minutes that we've already done, and that of course will leave us with 1 hour and 45 minutes.